Hello everyone, welcome to my channel Chemistry with Mishal. Let's discuss the successive ionization energy. Successive ionization energy is one of the very important topics. You can see many tables and many questions and many graphical questions in your exam about the successive ionization energy. So let's crack the concept of successive ionization energy. What does it mean by successive ionization energy? Like for example, when you are removing first electron, like for example, this is a first ionization energy, second ionization energy, third ionization energy, fourth ionization energy, fifth ionization energy. This is called the successive ionization energy. When you are removing the first electron from any atom, so this is called the energy required to remove the first electron from valence shell. This is called the first ionization energy. The energy required to remove the second electron, this is called second ionization energy. The energy required to remove the third electron, this is called third ionization energy. And energy required to remove the fourth electron, this is called fourth ionization energy. Fifth, sixth, seventh, eighth, ninth, and so on. So if your examiner is giving you data about the successive ionization energy and how you can conclude, how you can predict that this element, this atom has how many electrons in the valence shell. Like you can tell the valence shell electrons, you can tell the valence shell electron of any atom, valence shell electron of any atom by just looking at the table of their successive ionization energy. Okay, so how you can do this? So first of all, look at the value of, for example, this is a lithium. Okay, so for example, ignore it, like you don't know where is the lithium located in the periodic table, so you don't know about this. You will just look at the successive ionization energy for the lithium: first ionization energy, second, third, and fourth. So you will focus on the values. The lithium has first ionization energy 520, and its second ionization energy is 7298. Then third ionization energy is 11,000. Then fourth ionization energy is 16,1905. So the difference between 7,000 to 1100, 11,000, it's like the difference of 4,000. Then 11 to 16, again the difference of 4,000. But if you look at the difference between the first and second ionization energy values, ionization energy we measured in kilojoule per mole. So it means they are giving you measurement in kilojoule per mole. First ionization energy value was 520 kilojoule per mole, but the second ionization energy was 7298. So there is a big difference between the first ionization energy and second ionization energy. So it means it is a difference of like 7000 kilojoule per mole. So it shows that lithium has just one electron in the outermost shell. In the valence shell, an atom can only lose their valence electron easily. So lithium has just one electron in the outermost shell. So that's why it's first, there is a big difference between their first and second ionization energy. Then look at the sodium and then look at the potassium, because sodium and potassium, we know that they belong to the group 1. They also have the one electron in the outermost shell. So same thing you will look for sodium and potassium as well. That's There is a big difference of ionization energy for the sodium between the first ionization energy and second ionization energy. And then for the potassium, it is same. First ionization energy is 419 and second ionization energy is 3000. Like 400 to 3000, there is a difference of 1700. So it shows that lithium, sodium, and potassium, they all belong to the group 1, and they have just one electron in the outermost shell. Now look at the group 2 elements. Group 2 elements are beryllium, magnesium, beryllium, magnesium, calcium. These are group 2 elements. Now look at their successive ionization energy. For the beryllium, the first ionization energy is 900. Second ionization energy is 1757, and the third ionization energy is 14,000. So 900 to 1700, this is not a much difference, like the amount has been doubled. You can say that, because if the first ionization energy is 900, so the second ionization energy, it is almost 1700, 1800. So it is, you can say that it has been doubled. So this is not a much big difference. But 1700 to 14,000, this is a very much big jump in successive ionization energies. So it shows that the group 2 elements, they have just two electron in the outermost shell. That two electron they can lose easily. So that's why their first and second ionization energies values are small, and there is a big jump between the second and third ionization energy. So it means for the first group element, there would be jump between the first and second. For the second group element, there would be jump between second and third ionization energy. Their third ionization energy would be very high. So same thing you will look for the magnesium and calcium because they are from the group 2. They have the 2 electrons in the valence shell. So you can look at their successive ionization energies. Now you can go to group 3. For the group 3, boron, aluminium and gallium. Boron, aluminium, gallium, they are group 3. We know that group number tell us the number of electron in the outermost shell. So boron, aluminium, gallium, they also have the 3 electron in the outermost shell. If you look at their successive ionization energy, their first ionization energy is 801. So now it is 2427. Second ionization energy. Third ionization energy is 3659. But their fourth ionization energy, it has been shifted from 3000 to 25,000. So this is a big jump. So it shows that boron can lose just 3 electron easily. Then the same thing for the aluminium and gallium. There would be again big jump from the third to fourth ionization energy. For the gallium, again there is a big jump between the third to fourth ionization energy. So the point is, if your examiner is giving you the successive ionization energy, you can predict that this element has how many electron in the outermost shell. And we know that if you know the electrons in the outermost shell, you can tell the group number where the element could be present. Okay, now look at the graph, because graphical questions are very important. The graphical questions are the favorite one for your examiner from the periodicity. So what is this? What the graph tell us? You should know how to read the graph. In this graph, for example, this is a first graph. This graph is just for the group 1 element. So we know that for the group 1 element, there would be the big jump between the first ionization energy. So the graph has been plotted between the ionization energy values and the successive ionization energy, and they can also give you the number of electrons which has been removed on the x-axis. So when the first electron has been removed, so ionization energy is this. But for when the second electron has been removed, so this is a big difference for the lithium, big difference for sodium, and big difference for potassium. Okay, so we can see that there is a big jump from the first ionization energy to the second ionization energy for the lithium, sodium and potassium. Okay, lithium, sodium and potassium. And if you just look at, if you compare the values of lithium, sodium and potassium, their ionization energy, so you can see that their first ionization energy, they were very close together. They were very close, like you can see lithium 520, sodium 496, 419. So they were very close. But their second ionization energies, you can see that 7,000, 4,000, 3,000. So lithium has highest ionization energy, then there is a sodium, then there is a potassium, because we know that they are in the one group. So down the group, ionization energy values decreases. So that's why you can see their group, the lithium, sodium and potassium. If you just compare their ionization energies, so lithium has highest ionization energy. So this curve, it is for lithium, this curve is for sodium, and this curve for potassium. So your examiner can set the question, they can give you such type of a graph, and they can ask you that which graph represents the lithium, which graph represents the sodium, which graph represents the potassium. So you can see that, you can understand in just 1 minute that the highest ionization energy, this shows it is a lithium, then there is a sodium, then there is a potassium, because down the group ionization energy values decreases. Okay, for the next, we are going to discuss the group 2 elements. So same thing, you will look for the group 2 elements. Group 2 elements, there would be the big difference between the second ionization energy and third ionization energy. You can say there is a big jump between the second ionization energy and the third ionization energy for all the 3 elements of the group 2: beryllium, magnesium and calcium. So again, for example, if they are giving you such type of a graph and they are asking you that which graph represents the beryllium, magnesium and calcium, so you can see that this is a beryllium because it has highest ionization energy, then there is a magnesium, and then there is calcium because they are in the same group, and down the group ionization energy values decreases. The next thing is group 3 elements. The same thing, you will look for the group 3 elements. For the group 3 elements, there would be the big jump between ionization energy of the third and fourth. There is a big jump. So it shows that boron, aluminium and gallium, they have just 3 electrons in the outermost shell. 3 electrons they can lose easily. and for fourth electron there we would have to give the large amount of energy. And again boron have high ionization energy, then there is a aluminium, and then there is a gallium. Okay, so look at the some general key points. You can see what they are saying: the large jump in successive ionization energy occurs after all the valence electron have been removed. So the big jump between the successive ionization energy, it will take place when all the valence electrons have been removed. And the general rule is the number of valence electron is equal to number of ionization before the jump, before the big jump. So number of the ionization before the jump, it shows that how many valence electrons were present there. And the same thing that I have told you, that the group 1, the big jump would be for after the first ionization energy, for the group 2, big jump after second ionization energy, and group 3, the big jump after the third ionization energy. So all of my students, these are the key points about the successive ionization energy. You can written all these points on the paper, and please please keep memorizing them, because your examiner is going to set the same type of question, like this type the same questions you will see again and again in your past papers about the successive ionization energy. Sometimes they are giving you graph and they are asking you to predict the element. Sometimes they are, so mostly your examiner set the questions about predicting the element, like what would be the element. They will give you the successive ionization energies.